Hey guys, this is Brian here from South Florida Technical Training. Because of the COVID-19 outbreak we have in South Florida here and basically the whole world, our classes have been shut down and we can't have actual classes. So what I'm doing is I'm making some training videos to help the people in my classes and to help people in other schools and everywhere else just kind of keep track of things. Now, I'm going to be covering mostly basic electrical. I know it's not the most exciting subject, but there's lots of cool videos out there for engine repair and transmissions, turbochargers, all that kind of stuff, but there's nothing for basic electrical. So what I'm trying to do is I'm just trying to make something for basic electrical. I apologize, it's not going to be the most exciting videos in the world, but it is the most important videos for you to be good in your automotive career. If you want to get a bunch of ASEs and get a bunch of certifications and really be a good technician, you're forced to learn basic electrical, and that's what I'm focusing on. What is electricity? It is simply the flow of electrons from one atom to another. Think of an electron as a tiny magnet in an atom. When we place a magnet near a metal object, it pulls it with it. The same thing happens when we move a magnet near a wire. This is how we make electrical power, simply moving magnetic fields. The very basics of electricity is in order for electrical components to work, we need a complete circle for electrons to flow. If any part of the circle is not complete, electricity will not flow. This is called an open circuit. When a switch is closed, this allows electrons to flow. When a switch is open, this does not allow electrons to flow. This is called an voltage is electrical pressure. Voltage is how hard the electricity is pushing. There are two types of voltage, AC and DC. AC, DC. Direct current is where the voltage flows in one direction. We set our meter to DC setting. We can measure DC voltage drop from one place to another. The term voltage drop means we are simply measuring the difference in voltage from one point to another. If we measure from positive to negative of a battery, we simply are measuring the voltage of the battery. If a switch is closed and everything is perfect, we should have very little voltage drop. We are measuring from positive to positive or negative to negative. 12 minus 12 equals 0, and 0 minus 0 equals 0. So our meter will read 0. A voltage drop is simply the voltage difference from point A to point B. AC voltage is alternating current voltage. AC power switches polarity from positive to negative. We set our meter to AC voltage to measure this. The outlet in our shop and our homes use AC power. A great example in a car for AC voltage would be a wheel speed sensor. When we spin the hub, the wheel speed sensor generates AC voltage. The second thing we need to understand in electricity is current. We measure current in amps. If electricity were water, the current would be how much water is flowing. The more water that is flowing, the more work that can be done. We need current to get work done. The third thing to remember in a circuit is resistance. Every electrical circuit has a specific resistance. We measure resistance by setting our meters to ohms and measuring the resistance in ohms. If the resistance is low, a circuit may burn. This is why we have a fuse. So if the circuit pulls too much power, the fuse burns to protect the circuit. The resistance is what makes sure the amount of current or amps is correct. If the resistance is too high, a light may be dim or a motor may spin slow. A fan, where the wires have high resistance, will spin slower than it's supposed to. Often a person will blow a fuse because the resistance in a circuit is too low. What they do is install a bigger fuse. Well, the fuse's job is to protect the wiring and components. And if you install a bigger fuse, the current becomes too much for the wiring, and then the wiring burns. The relationship of voltage, amperage, and resistance can be calculated using Ohm's Law. Ohm's Law states it takes 1 volt to push 1 amp through 1 ohm of resistance. If you increase the voltage, you increase the pressure. This will force more amps through the circuit. If you increase the resistance in a circuit, this will reduce the current flow. These numbers are proportional to each other. As long as you know any of the two numbers, you can calculate the third number. Thank you for watching. I'm still learning to make these videos, so things will improve. Just like our page, and I'll try to make better ones as time goes by.